Good morning and welcome to part 3 of my video series on Chapter 9, Configuring Multi-Area OSPF. Um, I've talked about the dynamics of it. Now we get to the mechanics. At the end of this there are some labs. I've already done one of those demos. I will probably do the other one later today. If not, it will be early next week. Um, so if you're still working on Chapter 8, good deal. If you're already into Chapter 9, that's good too. So let's talk about how to implement multi-area OSPF. We're going to be talking about both V2 and V3 simultaneously. So there's not going to be another little series of videos on OSPF V3. Once you can do this with V2, you can do this with V3. It's kind of the mechanics of what really and truly, once you can set up, once you understand how to implement a single area OSPF, you just have to think about what areas you're using for which networks for multi-area OSPF, and you're good to go. So let's talk about how this works. So there are 4 steps to implementing multi-area OSPF. Step 1, requirements. Step 2, define your parameters. Step 3, configure the implementation based on those parameters. Step 4, verify. This is the systems development lifecycle all over again. Understand your requirements. Design your solution. Build your solution. Test your solution. I was trying to pause there. So as I said, this is the systems development lifecycle in a nutshell. First off, you understand, when we say the network requirements and parameters, we're talking about the size of the network, the physical and logical structure of the network, and we're not even really talking at this point about subnetting. We're more or less talking about organizational structure, and thinking about the security needs, say, for example, the security needs, the bandwidth needs, and indeed the physical location of specific sections of the network in terms of who's going to be using it, or what kind of resources are going to reside there, etc. We're thinking in terms, in step 1, you're thinking like a network architect, a network engineer. More architect than engineer, really. In step 2, we start thinking more like the engineer. You look at your addressing plan, your network topology, and then you can decide, is this single area or multi-area? Because we are talking to some degree about the scale of the network. That may be a key point in favor of single versus multi. Say, for example, you don't have for example, if you've got a very large number of routers, then you don't really want all of them talking to each other, converging on a single LSDB, even if they're in a very small area. That would be too difficult. That would take too much time converging originally. So you might need to break that up into multiple areas. Conversely, if you have a small number of routers that you think, hey, I've only got 10 routers, they can all talk to each other. I don't need multi-area OS. What if 3 of those 10 routers or 4 of those 10 routers are 50 or 100 miles away down a slow WAN line? Do you really want all that the intra-area network traffic going down that little bitty WAN pipe? Probably not. So if you have a branch that is far, far removed, then what you can do is make it an area unto itself. Set up area summarization, which we talked about, which we will discuss in lab 9228. If you watch that set of videos first, you've already seen this. Anywho, you can set up your area summarization so that instead of having to advertise lots of little networks across that WAN link from your regular area into your backbone or whatever it is, then you can send a summarized aggregated network and use less bandwidth. So once you've determined your areas, how many there are and where they are and how big they are, that'll have some relation, that'll have not just some, but a great deal of relationship to the addressing plan. It is absolutely essential to have a logical, hierarchical, summarizable, really, addressing plan, so that all the networks over yonder fit into a space together and make sense together. And all the um, networks on the other side of that one link also fit together mathematically and logically. And you're not just going to want to think in terms of your big areas, like this little network over here and the big network over there, and make sure they summarize. You might want to do that within those areas as well, because you don't just have to do this area summarization things at area boundary, range summarization at area boundaries. You can find other ways of doing this, so that if you have a section of your network which all fits together and it's all going to go through to another part of the network from through a single router, maybe you do your summarization there. So look at everything, the areas, the topology, the addressing plan, all of it. Then once you know what it should look like on paper, frankly, this might be a really good step 3 before you even go to start on step 3. Definitely before you go to step 4, it might not be a bad idea, if you've got, say, Packet Tracer or GNS3 in your back pocket. It might not be a bad idea to model the whole network in software, virtually, and then see, okay, does this actually work? Rather than spending dozens or hundreds of hours deploying the network, configuring the network, doing all of that and discovering, wait, this is a bad idea. So if you feel like doing a little bit of your verification at your desk in a network simulator like Packet Tracer or GNS3, go for it. You'll find some of the problems that way. Then, of course, once you've thought about the solution, designed the solution, pre-tested the solution, you've got to actually go out and do it. Put each router in its areas, make sure they all converge, and then verify. So let's talk about how that's going to work. I'll be right back.